Okay, this is showing how we got the inverse matrix, um, the formula for the inverse matrix. So this is what we're going to work with right here. Okay, so just remember that if we have something that we multiply by, we can multiply it by its inverse to get 1, which is the identity, correct? So if I have 8 and I times it by 8 to negative 1, I get 1. And so this is what we call the inverse matrix, or inverse. It's not the matrix, but you get what I mean. So we're going to do the same concept with a matrix. So let's start out with the first matrix is going to be A, B, C, D times some matrix is going to give us what in matrix world, this identity matrix, is 1, 0, 0, 1. Okay, so we're going to figure out what it is that we multiply by here to get that 1 matrix. So just for the sake of argument, I'm going to put just some variables here to figure out if we can know what value to put in each one of these locations to get the identity matrix, then we will have figured out how to solve for all cases. And I get a sneaking suspicion that it's going to end up just like the one that we have for our formula. Let's take a look. So we're going to start with multiplying this row by this column. All right? So I get A, E plus B, G equals 1. So notice that the output here would end up right here. Right? Okay. Oops. Okay, so we're going to just get rid of this part. I was hoping it would just work, but it didn't. Okay. All right, so now let's do the next one. So we're going to go row against the second column. So first row against second column. That gives us AF plus BH equals 0. Now we'll go with second column against first row. Should give us CE plus DG equals 0. And then finally the last one, which is second row, first column, which is second row, second column, which would be CF plus DH equals 1. All right, so if we can figure out what goes in each one of these locations, then we can figure out the value that would work for it. So let's try first solving for, let's go first with E right here. So to solve for E, I'm going to go a little skinnier here. We're going to treat this side, because this is where we have e's. We don't have any e's on the other side, so we're only worried about these two equations. We want to solve for E. And so to do that, we're doing a system of equations, and we're going to eliminate G. And to do that, we first look at the coefficient of both of these, recognizing that one of these we have to do a negative so that it'll work. So that it'll work. Okay. This was AE. This was CE. Okay, so to do that, the top one here, we're going to multiply everything by D, and the bottom one, we're going to multiply everything by negative B. All right, that gives us, and notice that I'll just put these in alphabetical order, A, D, E plus B, D, G equals D, and negative B, C, E minus b, or plus and negative b dg equals 0. And now if I add these two together using the elimination, these two go away. They bdg minus bdg is 0, leaving left over ade minus bce equals d. Now we notice that these terms both share an e, so I can rewrite it using distributive property. AD minus BC E equals D. And now we want to divide both sides by AD minus BC, giving me E equals D over AD minus BC. So as we write the answer to this, we'll just do it over here, and I'll keep coming back up to it. So in position E, that's the first part here, it's going to be D over AD minus BC. Okay, that's the first place. That's position E right here. Now let's try position F. So we're going to work with this one. I'll use blue. And we're going to work with F. So with that one, I want to work with this pair of equations. We'll just go straight down. And so we want to eliminate H in this case. So we'll do the same process where we'll times this part by negative B and this part by D, which gives me ADF plus BDH equals 0. And then the second one is negative BCF minus BDDH equals 1. Cool. Add these together. BDH goes away. 0 minus 1 is a negative 1. Okay. So we have ADF minus a BCF. Oh, no, it's not a 1. It's not a 1. It would be a minus B. Okay. Gives us a minus B. And yeah, my pen changes colors. I can't change it. It's just weird. Okay, so we notice here that these two terms share F, so I can distribute that out. I can do AD minus BC. All that times F equals a minus B. Now I can use the same procedure. And F is going to be a minus B over AD minus BC. And then we'll put this back up in the resultant matrix. And we get for position F, which we need to remember where that's at. It's right here. But position F is going to be a minus B over AD minus BC. And if I follow the same pattern, doing the same kind of thing, solving for the variables that are missing, just to make it a little quicker here, this one will end up with a negative A over AD minus BC. And then the last one will be A, no, not A, it should be C. C. And then A here, which would be AD minus BC. Okay, and that results, I don't need to blow it down. Notice that I can factor out the AD minus BC, which gives us our formula here. And that is the proof. Hopefully that helped.